Neco Mathematics 2026 revision class. The questions that you should be expecting in your exams tomorrow. All right, so we've got some questions here, and we'll be solving them, one after the other. And peradventure you have questions relating to them, please do well, or feel free to put up your questions right there in the comment section. We'll attend to them in due time. All right, so we'll begin the questions right away. Okay, some of them I have the questions right there on the board, while I put some questions newly on the board and I solve at the instant. All right, so we'll begin with the very first one. Now, the very first question here is about set. All right, here we've got all right, so x is a multiple. X is a multiple of 2, and B, another subset. We're given that x is a multiple of 3, and C, we've got another subset, and x is a factor. X is a factor of 6. Then we're asked to find, okay, A complement intersection B complement or union C complement. All right, so we've got this question. We solve it right away, then we'll proceed to the next question. All right, so here we have the signature, this, okay, or this, to represent universal, meaning the encompassing set, and where we have what we call the subset, that is the divisions, the compartment of the universal. So here we've got 3 subsets and a universal set. Here, some of the sets, sometimes you may have the set defined. Sometimes you may be the one to define them. So here we need to define the set. Here, ordinarily, the universal set here means all the elements between 1 and 10. So I can renumber them to have such as this, okay? All right, just quite very direct. So I've been able to renumber them. I've been able to define them, so to say. Then the subset also, we come over to the subset A. And then here we're told that the subset A are elements that are multiples of 2. That tells you that multiples of 2 can be limitless. But in this context, you need to limit yourself with the maximum value of the universal, that is 10. So what are the multiples of 2 within this range of values? Now we've got 2 to be the multiple. Add 2 again, making 4, plus 2 again, 6, plus 2 again, 8, plus 2, 10. Of course, we stop here because the maximum number in the universal is 10. All right, so we proceed to the next subset. The next subset here told us that the element here are multiples of 3. Okay, so here multiples of 3 becomes 3 rather. Addition of 3 again makes it 6. Another 3 makes it 9. We can't exceed this because the next one is going to be 12. More than the maximum here. So we've got this to be the element in B. Now let's proceed to the very third subset, and that's subset C. Okay, we've got subset C to be elements which are factors of 6. Factor simply means numbers that can divide the specific number here, 6, which we know that 1 can divide all numbers. Okay, 1, 2 can also divide 6. Okay, we've got another factor, 3, and of course 6 itself. So I've been able to define all the elements. Then I can proceed to evaluate what we've been asked to do. Now let's begin with this here. A complement. A complement, and of course the signature means complement. It can either be this, or it can also be, okay, A prime or A superscript C. Now either of the two connotes, complement, and complement means element that you can find in the universal, but you do not find or you cannot find in that specific given set. So what are the elements that I can find in you in the universal, but I do not have in A as a set? Now I've got the A to be even number, so to say. So I can bring this out to be 1. Okay, since I have 2 there, 3. Okay, 5, 7, 9. These are elements that we can find in the universal, but unable to find in A. Now we proceed to the next one. That's B prime. B prime. B prime, the same procedure. Element that I can find in the universal, but I cannot be able to find here. So I will just accept this one. I will go I have 1, 2, 1, 2. I've got 3 here, then 4 here. Okay, 5. I've got 6 here, then 7. Okay, 8. I've got 9 here, then I move to 10. Okay, so now I move on to the very last one here. That's C prime. C prime. Now C prime also means element that I can find in the universal, but I cannot find in the given set C. Now I've got 1 here. Okay, I've got 2 here. I've got 3 here. So I'll begin with 4. Okay, 5. I've got 6 here. So 6 should not be here. 7, 8, 9, and of course 10. And so then I move by the signature here. The symbol in set here connotes intersection. That is, elements that are common to this given set. While the symbol here means union, combining 2 different sets together. All right, so now let's kick off with this. What are the elements that you can find in A prime at the same time you can find in B prime? So let me do that. A prime intersection B prime. I've got that to be an intersection. I've got 1 here, 1 in both of them. I've got 5 in both of them. I've got 7 in both of them. I think that's all that I can find in both of them. Then the very last thing we do is union of this given set and the C prime. So A complement intersection B complement, okay, union C complement. I've got that to be by uniting this set and this set together, usually arranging them in ascending or descending order. So let me begin with the list number 1. Okay, the next number that I can have there as the list, 4. Okay, 5. Now notice I have 2 values for 5 here, so you've got to pick one of them. 5, no 6. I move to 7, then 8, and of course 9 and 10. So we've got the answer to the very first question to be this. All right. So we'll move on to the next question. The next question we've got here, it's a subject of formula. Okay. Move on to the next question. That's subject of formula. Okay. Just very concept based, and of course, principle based. You just got to learn the principle from here and adopt it on however the question will come to you tomorrow. All right. Now the next question we've got here, okay, here we're giving P raised to power 3 over 2 equal to RK over Q minus MS. And we're to make Q the subject of the formula. Now that's the next question. We are to make Q the subject. What does it mean? That is, Q should be equal to the rest of the variables. How do you go about it? I'm going to give you a very, very simple and direct, method in solving this. Now, notice Q here. All right. Now, let's take care of the other debris by moving them to the other side. Now, we've got this one here to be connected by subtraction sign. So I can move this to the other side to become positive. So it becomes P raised to power 3 over 2, okay, plus MS, then equal to RK over Q. The next question is, how do I make this Q equal to the rest of the variables? I'm going to give you just one trick here, okay, just a line that you will, put up and you have your answer. All right, I'm sure you're expecting that. Now, how do I make Q equal to the rest of them? Now, check this. If I say multiply both sides by Q squared over RK, multiply both sides by this. Let me do that here, and I'm going to show you something here. Okay, multiply both sides here by Q squared over RK. Now, what do we mean? Now, it will give us such that RK, cancel out RK, then Q, okay, cancel one of them. We've got Q alone here now. All right, okay, so that, okay, we have Q here. All right, so I can, okay, let me bring it back. Okay, so I've got it to be RK over Q. All right, so here I can over 1 and cross multiply. Okay, I've got to cross multiply from here. So I've got RK all equal to Q, open a bracket, P raised to power 3 over 2 plus MS. Okay, plus MS. All right, from here. Now, the very last thing we do is just to get rid of this. as though a debris. Get rid of this. Notice that they are connected by multiplication sign. Now, anytime you've got a variable connected by multiplication sign, to take it off, you divide. Okay? If it is divided by it, to take it off, okay, or rather this way, if it is divided by it, to take it off, you multiply. So you've got here to multiply by 2, it goes off. Okay, then you have a equal to 8 in this case. Now here it is connected by multiplication. To get rid of it, you divide. All right, so that's the way out of this analysis. So from here, I've got to take care of this debris by dividing both sides by p raised to power 3 over 2 plus ms. I've got that here also, p raised to power 3 over 2, all right, plus ms. So this goes up with this. Then we've got q, therefore, to be equal, okay, just very and quite easily done, to be equal to rk over p raised to power 3 over 2 plus ms, okay? Isn't that interesting and direct? So we've been able to find or to make q the subject of the formula. That leads to the next question, 2b. The next question here tells us that, okay, given that k equal to 4 and m equal to 15, and of course p equal to 3 and r equal to 10 and s is equal to 0.2, we are to calculate or find the value of q. All right, find the value of q. We've been able to make q the sort of formula. What are we expected to do here? Just substitute the respective values in the formula and you get your q. Now recall that q is equal to rk, okay, over p raised to power 3 over 2 plus ms. So I've got to impute the respective values where they belong in the expression. R, we're giving r here to be 10 multiplied by k. We've got k here to be 4, okay, then p is given here to be 3 raised to the power of 3 over 2, okay, plus m, 15 multiplied by s. We've got s here to be 0.2. All right, so q here, without a waste of time, we've got here to be 40. Okay, this is 3 raised to the power 3 over 2. All right, now I can still put it back. I will evaluate it very final. 15 multiplied by 0.2. Okay, that's 2 over 10. All right, so we've got here 5 here to be 2, 5 here 3. Okay, then eventually I have 3. Okay, all right, that's 30 over, that's 3. So I've got this to be 3 without a waste of time. And so we've got 40 over 3 raised to the power 3 over 5. 3 over 2, let's get that with the calculator. 3 raised to the power 3 over 2 also means 1.5. So I can have it 3 raised to the power 1.5. All is equal to, okay, I've got that to be 5.196 plus 3. Permit me to do it directly. So I have plus 3. Okay, then we've got that to be 40 over 8.196. Then finally, while I still have this on the screen anyway, I will say 40 divided by answer equal to, then I've got q finally here to be 4.88. 4.88. Okay, I guess we're asked to put the answer to the nearest whole number. So the nearest whole number, we've got that to be, next whole number gives us 5. So we've got the value of q to be equal to 5. So here, we've been able to solve the first 2 questions. We proceed to the rest of the questions, all right? Now, I want to appeal to you that you learn the principles from here and follow them meticulously, all right? You'll be glad you did anyway. All right, so moving on to the next question. While we come to this later, the next question here tells us, okay, something related anyway. It's something related. All right. Here it's quite easier, but related to this. Now that's 2bii. 2bii. Here the question says, if x plus 2y equal to 5x minus 10y, find the ratio of x over y. Find the ratio of x over y. Okay. All right. I just got the feedback from some of us there. Okay, that I seem to be too fast. Admit me. All right. Okay, so I'll take it quite slower now. Now, okay. Now we're given this equation here, and we have to find the ratio of x over y. This is very simple and direct. How do you go about it? Now, okay. Let me rewrite the expression here. X plus 2y equal to 5x minus 10y. Now, notice this x, the numerator. So let me make x the subject of the formula. Now, that's the way out of it. So I have x. Bring this 5x closer. What's the sign here? Positive sign. It comes closer to become minus 5x. I'm sure you can get that. Equal to, I'm having to take the 2y back to this place here. But here, I've got the minus 10y to be left behind here, while the plus 2y crosses to become minus 2y. All right? So here, x minus 5y, it gives us minus 4x, equal to minus 10y minus 2y, gives us minus 12y. Then the next thing I do, like I said, we've got x to be the numerator here. So you will do as though you want to make that x the subject. Okay? How do I make x subject the formula? You simply divide both sides by minus 4. So minus 4 here, minus 4 here. So that cancels out. So we've got x equal to, of course, you know, minus takes out this minus, and 4 takes out this 12 to become 3. So we've got 3y. Now, the next question is this. We are not asked to find x. Neither are we to find y, but we have to find x over y. There are two ways you could have solved this, but this is the easiest way I want to show you. Now, the next thing is, how do I get, I've been able to make x equal to 3y. How do I make y come as a denominator to that x? Meaning, how do I make y come beneath here? You simply say, multiply both sides by 1 over y. Let me show you what I mean. So if I do that, 1 over y, you discover that y goes out with this y here. Then you have x, okay, this is over 1. Y comes under here eventually as over y. Then you have 3 left here. So you have been able to find the ratio of x to y very, very easy and direct. Okay, I'm sure you've learned something there. All right, now we'll move on to the very next question. Move on to the next question. Now it's becoming interesting gradually. It's becoming interesting gradually. All right, we are here for you anyway. Okay, we've got you covered for your exams tomorrow, and I cannot wait to receive, you know, your good compliment and your testimony for the exam. And in case you're just joining us for the very first time, please do well to subscribe to the YouTube channel. Okay, like and subscribe. We would appreciate that. Thank you. All right. Okay. All right. Now, move on to the very next question. Becoming interesting. In fact, I'm becoming excited too myself. Okay, I'm liking it gradually. It gives me joy solving mathematics. Okay, all right. So the very next question here, it's partly, let me get that. Okay. Sorry, I'm having to get the question. Okay. Now I've got the next question, number 3, here to be this. Here, given DCB and a right angle here, E. Here, okay. And we're told that BCD is equal to 108 degrees, while DE is a perpendicular line. Perpendicular line. Okay, this is a perpendicular line. Then we have to calculate angle CDE. Okay, so somebody is smiling already. Okay, now CDE. Now notice we're given that the triangle BCD here is an isosceles triangle. What do you mean by isosceles triangle? Okay, isosceles triangle means a triangle where only two of its sides are equal. Okay, and when we say equilateral triangle, it means a triangle where all the three sides are the sides equal. Then when we say scaling triangles, we've got those three types of triangle: equilateral triangle, isosceles triangle, okay, and of course scaling triangle. Scaling triangle, we've got these three types of triangle. Now let me take it again for the sake of those people that are just, that may not understand what I said initially. Equilateral means when you have a triangle such that all the three sides are equal to each other, then the triangle becomes equilateral. Okay, such as this here. Then when we say triangle is isosceles, as we have got here, it means just only two sides are equal to themselves. Okay, isosceles. But when we say scaling, okay, as we may have, however, when you have the three triangles, the three sides to be different from each other, okay, you've got that triangle to be scaling triangle. All right. Now here we're told that BCD is isosceles, and we're given BCD as 108. BCD, that is this angle here, as 108 degrees. Then we have to find CDE. Quite direct and easy. CDE, meaning we have to find this angle addition or added with this angle 90 that we see obviously here. So we've got CDE all together. So now let me call this place theta here. So it means that CDE is a combination of two angles together. Angle of CDB plus angle BDE. Okay, to give us all of this angle. All right, meanwhile, this angle alone is giving us as theta, plus this angle here is giving us as 90. Okay, so the bone of contention here is, how do we get this theta? Such that having gotten theta, we simply add it with 90, and that gives us the angle CDE, and that's all. How do you go about it? Now, let's get back to the triangle. We're told BCD is isosceles, meaning that two sides are equal, invariably means two angles within the same triangle too are also equal. But the question is, which of the two angles are the equal angles? All right, now let's get that done. Now, let's get the two sides that are equal first. Then any angle within that triangle that are facing those same equal sides are the equal angles. Now, how do I mean? This side is faced by this angle here, and this side is faced by this angle here. So that means that these are the two angles equal to each other. If here is theta, here also must be that same value, since you can agree with me that they are both equal, being isosceles triangle. So then we'll move further from there. Okay, just very direct and easy. Okay, from there we have okay, and you know that some angle in a triangle is always 180. So we have here 108, this angle plus this angle together, plus the other angle gives us 180. Now, since you're working with you're not objecting, you need to indicate all of these things. You simply write angle in a triangle. Angle in a triangle. Okay, this is enough to tell the examiner what you actually mean. Okay, because not only angle in a triangle gives us 180, we call it angle in the straight line 180. So which one makes it 180 here is why you should indicate here. All right. Now, moving further, we've got 108. This one gives us 2 theta equal to 180. Okay, making theta the set of formula we've got. This moves to the other side, leaving behind 2 theta. So we have 180 minus 108. So we've got 2 theta here. If I subtract this, I've got that to be, okay, 92. 72. All right, here, 72. Okay, now to find theta here, I divide both sides by 2. So theta gives me 36 degrees. Theta gives me 36. 72 divided by 2 gives me 36. So I've been able to find theta 36. I can come back here and say 36 plus 90. That gives me altogether 126 degrees. Quite easily done and direct. All right. I want to believe somebody is smiling already. Okay. All right. So we've got to proceed to the next question so that we can reach those, essential questions that would be finding tomorrow. Okay, now we've got the next question. Interesting. 3B. Okay, 3B. Let me take this off. The next question. Now the next question is on trigonometry. 3B. On trigonometry, it says if tan x equal to root 3, okay, for 0 degree less than x less than 90 degrees. Okay, we have to find cos square x minus sine x over sine square x plus cos x. So how do we go about this? Okay, now this is another interesting question that we will find, or we can find, okay, in the course of the exams tomorrow. All right, so here now we simply notice this angle signature here. Now that connotes that now when we have such angle or such triangle as a right angle triangle, that's the first thing. Then we get this allocated on this right angle triangle with our acronym SOHCAHTOA. All right, SOHCAHTOA. I'm sure you are remembering that again. Okay, you must have been taught this in your junior secondary school. All right, so here we're giving tan. So I will go in the arena of the TOA. So here we've got the tan x originally to be opposite, okay, over adjacent. Then I will compare what we're given as a tan x to the original, implication, to the original formula of the tan x. Now the tan x we're given here was given us as root 3, as though it's a whole number. But probably I can also say over 1. Okay, knowing that anything over 1 still gives us the same thing. So that I can relate that with this, knowing that the opposite is the root 3, adjacent is the 1. Then I will have them implanted on this triangle. Now let me make this place to be the angle x. Remember it is tan x. It could have been tan theta. So here becomes a theta. So since it is tan x, here becomes the angle x. Then here automatically happens the opposite. Opposite, hypotenuse, and the adjacent. All right, so let me get these values implanted here. Now the numerator gives us the opposite. So opposite is got to be here, root 3. The denominator gives us as the adjacent 1. 1 is adjacent is here, not here. So I've got to find the hypotenuse first using Pythagoras theorem. Okay, using Pythagoras theorem. What does it say? It says that the square of the hypotenuse for a right angle triangle anyway, strictly, the square of the hypotenuse equal to the sum of the square of the opposite and the square of the adjacent. All right, so here I've got to find the hypotenuse, that's y. That's y squared equal to the opposite by giving us root 3 all squared, okay, plus the adjacent here is giving us as what? 1 squared. So how do we go about this? Okay, we've got y squared. Of course, you know this in your sword, analysis. Root 3 times root 3. Now, root 3 times root 3 gives us root 9. And of course, root 9 is a perfect square that gives back to 3. All right, so here we've got root 3 squared to be 3 itself, and y squared to be 1. So here, y squared equals what? 4. So how do you get y? You simply square root both sides. Square root here, square root here, such that square root cancels square. Then I've got y alone to be equal to 2. So I could erase this place here and make it back 2. So I've just found it to be 2. So I've been able to find the complete side of the triangle. Then I can get back to the equation, the question that we're asked to find, knowing that this cos square x here means cos x all square. Okay, I want to believe you understand what I'm doing here. Okay, cos square x means cos x all squared. All right, minus sine x all over sine square x 2 means sine x all squared. All right, plus cos x. Now let's get those things implanted, then we evaluate and we get the final answer. We'll move on to the next question. Very easy and direct. So here we also know from the SOHCAHTOA, from the acronym here, that cos is giving us as what? Adjacent over hypotenuse. Okay, here I've got it to be adjacent over hypotenuse. Notice that it is squared, so I have to square it. Okay, minus sine alone is just opposite over hypotenuse. Opposite over hypotenuse. The sign isn't squared here, all right? All over the sign here also, opposite over the hypotenuse. Okay, it is squared here, so I've got to square it here, plus cos theta, cos x rather. Okay, the same thing here, but not squared. Adjacent over hypotenuse, not squared. Now let's get those values there. Okay, now what is the adjacent here? 1. The hypotenuse, 2. Very simple. 2 raised to power 2 minus, what's the opposite? Root 3. What's the hypotenuse? 2. Okay, what's the opposite? Root 3. What's the hypotenuse? 2. Remember it is squared here, so I have to square it again. Plus, what's the adjacent? 1. What's the hypotenuse? 2. So I've got this to simplify, and I'm heading for the good answer. All right. Now, I think I can take this side off. And take this side off. I'm having to reserve this question because for probably to the last. All right, here. Now, square of this. Notice the square is affecting both the numerator and the denominator. So I've got that to be 1 over 4 minus root 3 over 2. Okay, here 2 is affecting both the numerator and the denominator. So root 3 square gives us 3, like we did the other time. I'm sure we can remember. Then 2 square gives us what? 4. And I've got that plus 1 over 2. So how do we go about it? Let me evaluate the numerator first. And I do the same thing for the denominator, and I divide both of them. So here, the LCM here gives us 4. 4 in 4 is 1 times 1, 1 minus 2 in 4, 2. 2 times this, we've got that to be 2 root 3. Okay, all over. Let me do this one directly too. We've got the LCM here to be 4 as well. Okay, 4 in 4, 1 times 3, 3 plus 2 in 4 is 2. 2 times 1, 2. All right, so here I have 1 minus 2 root 3 over 4. Now, notice this is the main division sign. So I can as well put it this way. Okay, I can make this division sign equally this way so that I have 5 over 4. Then finally, I reverse this. I change this to multiplication sign while the fraction that follows gets reversed. So I have 1 minus 2 root 3 over 4 multiplied. As long as this division sign changes to multiplication, the fraction that precedes it gets reversed. So 4 over 5. Such that 4 goes out with this 4. And we've got finally here 1 minus 2 root 3 over 5. Okay, we've got that to be the very, very answer, because we cannot add the real number and the sort together. All right, so we've got the very answer in this very form. Okay, quite easily done. All right, so move on to the next question. The very next question is becoming interesting gradually. All right, the next question is on mensuration. Mensuration. All right, so let me take this off from here. Okay. Okay, let me take this one too off from here. Now the next question here. Now this one, let me read the question to us while I go to the board to solve it. It says the ratio, okay, of the base radius to the slant height of a right circular cone is 2:5. If the total surface area of the cone is 224 pi centimeters square, calculate Roman figure 1, slant height, Roman figure 2, volume of the cone. Very interesting. Now let me go solving mathematics directly. We're told the ratio of the base radius. Okay, let me come with the diagram firstly. We're talking about a cone. This is a cone. A cone is a solid figure, okay, that has a circular base and a pointed vertex on the opposite side. Okay, a cone has one vertex. One vertex. All right. So here we've got a cone this way, such that we have what we call a base radius r, and we've got two heights: the vertical height, h, and of course we have the slant height L. Okay, these are the basic dimensions that you need to understand about the cone. All right, the base radius, the vertical height, and of course the slant height. And let me give us some formulas here. Okay, now for a cone, the curved surface area, meaning the area of the curved part alone, is given as pi RL. So that is, to get the area of the curved part, you've got to multiply the pi by its base radius by its slant height, not the vertical height. Notice what I put here. And of course, we have the total surface area. Now, I'm going to give us how this came about. It's actually pi r into bracket r plus L. So to get you the total surface area of a cone, you've got this formula which originates from adding the curved surface area, that is pi RL, and the circular base. That gives you the total, the encompassing surface. Okay, the curved surface area is this, then the circular base down. Of course, you know that area of a circle is pi r squared. So factorizing this together is what gives you this. All right, so now let us not, make it cumbersome. All right, so we've got that. The next thing about a cone that we could be asked is the volume of a cone. Now, the volume of a cone here is given as 1/3 pi r squared h. That is 1/3 times area of the base times the vertical height. The same thing applies to a pyramid. Any pyramid whatsoever. You can have a square base pyramid, okay? In a way, okay? In a way, a cone can also be referred to as a circular based pyramid. Now, for any pyramidal shape, the volume is always 1/3 times the area of the base. But because in this case here, a cone comes, all the time with a circular base. That's why we have an ideal, or we have a specific formula for that volume. Okay, knowing that it is the area, circle is the area of the base. Okay, but in other forms of pyramid, where it may come with several shapes on the base, so we wouldn't know the base it will come with per time. So it could be a square base, it could be a rectangular base, it could be a triangular base, it could be however. So the 1/3 times area of the base times its vertical height. And so that is exactly what the principle that governs the volume of a cone to be this. All right, so now let's move on to the question that we have exactly. All right, so here we're told that the ratio of the base radius of this cone and the slant height is given as 2:5. Okay, let me get close to the question. Okay, the ratio of the base radius to the slant height is 2:5. That's why I've got this. All right, moving further, we're told that if the total surface area, that is the TSA of the cone, is given as 224 pi centimeter square, we've got to find Roman figure 1, the slant height, okay, the slant height, and Roman figure 2, or letter B rather, we've got to find the volume of the cone. The volume of the cone. So how do you go about this very simple and direct question? All right. Now, since we're given the total surface area, so that tells you that I have to go through the rudiment of the total surface area formula to get all that we have been asked to do. So total surface area of a cone, like I gave you here, recall that total surface area of a cone is given as pi r into bracket r plus L. And here we're told that the total surface area is given us as this. So let me get the value where, okay, it belongs. So we have 224 pi. Okay, this is the value. This is not just a unit. Okay, equal to, since I have pi to be in the formula, in the value. So that tells me that pi should also still remain here and not replace it with 20/7. All right, so I should leave pi here, pi multiplied by r. Now, since we have to find slant height, so let me make from here, the radius in terms of the slant height. How do I mean? Okay, let me do that. Cross multiply. Okay, we've got 5r equal to 2l. Then to get r in terms of the slant, so divide both sides by 5. So here we've got r, the base radius to be equal to 2l over 5. So that means in place of r, I can also exchange it for this mathematically. So I've got r here. I can put it in form of 2L over 5. So I have 2L over 5. Then open a bracket, continue this. R again, I can replace it as what? 2L over 5 again. Plus L, I can start to leave L as L. All right. So now if you check through the equation now, I've got just specifically one variable, and that's L. Though I have pi. Pi will cancel out here. So leaving behind only variable slant height L. And that's what we've got to find here. If we were asked to find the base radius first, I would have made L in terms of the base radius. Then I insert that there. That would have been the best thing to do. But in this case here, I've got to make the R in form of the L substituted here, so that I can find my L with no stress. So here, I have my pi cancel out. Then we have 224 equal to 2L over 5. Okay, let me simplify this. Okay, let me simplify this. We've got the LCM as 5. 5 in 5, 1 times 2L, 2L plus 1 in 5, 5 times L, 5L. All right, so we've got 224 equal to 2L over 5. Now, adding this together, we've got it to be 7L, okay, over 5. Then moving further, I've got to multiply these two out. 2 times 7, 14. L times L, of course, L squared. 5 times 5, 25 over 1. What's the next thing? In an attempt to find the value of the slanted L, cross multiply 14L squared times 1, 14L squared. Then here we have 224 times 25. Okay, so the next thing is to divide both sides by 14. 14 cancel out here. So let me work with a calculator here to avoid any unnecessary error. 224 multiplied by 25. We've got that to be, okay, divided by 14. So here we have it as 400. Of course, that tells us that L squared being equal to 400. How would you get the slanted L? I want to believe somebody can do it right there. Okay, I wouldn't mind that you get the value of L and just put it on the comment section there. Okay, all right, so I will wait that to be put there while we go on to the next question. So while I'm reading the next question, please do well to put your answer right there in the comment section. Would appreciate it. Okay, all right, moving to the next question. The volume of the cone. Do we have anybody put the slanter there already? None. I'm waiting for us. Just a few minutes more. Huh? 20. Correct. All right. Now, who is the person? I would have to award that person maybe later in the course. Huh? Okay. The person should get connected with me shortly after the class. All right. So F. Huh? Somebody else?
Yes.
Somebody else?
Yes. Yes.
Oh, that's great. So how many people got the answer?
4.
4 of them.
Yes.
Okay, I'll get them noted. So here, you get the L by square rooting both sides. You square root this, square root this. Square root cancel square. So we've got the L to be equal to 20 centimeters. So the slant height for the cone has just been gotten as 20 centimeters. So I can proceed to finding the volume of the cone. How do I get it? Okay, it's becoming interesting more. This is our food. Is to solve the math of him who sent us while it is almost, our exam tomorrow. All right, so here the volume, let's recall. The next question, recall that I gave us the formula the other time. Volume of cone, okay, to be equal to 1 over 3 pi r square h. Then there will be a constraint here. How do I mean? We've got pi to be 22/7. Do we even have the base radius? I do not think so. Do we have the vertical height? I do not even think so. How? So we've got to find these two variables, then get them implanted here. So how do we go about it? Now, notice initially, I gave us a cone this way. Okay? A cone, vertical height, the base radius r, and the slant height l. That tells us that we have a right angle triangle also in a cone. And we've just got the slant height to be 20. Here, to be 20 centimeters. Base radius, we do not have it. But we were given the ratio of the base radius to the slant height to be 2 over 5 the other time. So that tells me that since the slant height already now has been gotten as 20, don't you think I can find the R? Will somebody get the R for me? But for the sake of time, I will not wait for that one. So you can do it to get the R and put it there. I'll check it later. So you have 5 times R. 5R equals to what? 40. Divide both sides by 5. Okay, we've got R to be equal to 8 centimeters. All right, so we've just got to the base radius here as 8 centimeters. Then, now here, notice that we need these two variables, R and H. I've just gotten R. I also need H. How would you get the H? Simply engage the Pythagoras theorem. Okay, like I did the other time. Okay, Pythagoras theorem here. Okay, just very, very direct. Very, very direct. All right, so here we have, now let me bring out this triangle. Okay, let me bring out this triangle. So we've got here to be 20. We've got here to be 8 centimeters, and of course here to be H. Now I'm finding H using Pythagoras theorem that says that hypotenuse square equal to opposite square plus adjacent square. So what's the hypotenuse there, everybody? 20 square, and opposite here. Either of these two can serve as the opposite. So let me go with H. Okay, plus adjacent as what? A square. So we've got that to be what? 400 A square plus what? 64. Now, collecting like terms here, we've got 400 minus 64 equal to A square. We've got that to be 3. Okay, let me subtract. Oh my God. 400 minus 64. Okay, that gives us 336. 336 equal to H square. Then H becomes square root of 336. Okay, that's exactly what you did the other time. Square root both sides. So square root of answer, we've got that to be 18.33 centimeters. Then I can proceed back to this volume and say 1 over 3 times 22 over 7 times R, radius 8. So that becomes A square times, of course, the H has just been gotten as what? 18.33. Then finally, okay, I've got this finally. Let me multiply all the numerators here. 22 here, multiplied by 64. 64, 18.33. Okay. Now don't attempt to jump the step. Write the numerators out first. So we've got that to be 25,808.64. Okay, to divide 21. So I just got to say divide by 21. Divide by 21, I have 1,228.9 centimeter cube. All right, why the cube? Because we've just got the volume, and that's the correct SI for volume. All right, so it's becoming clearer. We're done with that. Then we move on to the 5th question. Then we're getting close to this very question here, and I want to believe you're good for your exams tomorrow. You're good to go for your exams. Any comment right there? Any observation right there? No observation for now. All right, so move on to the next question right away with no waste of time. With no waste of time. All right, so here, the very next question, number 5. Now, very interesting question. Please take note of this question. Very, very interesting. Here we have numbers. Here we've got it as number of times. Number of times. Okay. Here we've got the number 1, 2, 3, 4, 5, 6. Then the number of times 5m, 55, 45, 25, and 40. Now look at that question. The question here says, while I read and you follow right down the board, if the probability of obtaining a 2 is or was 0.15 rather, probability of obtaining a 2 is 0.15, then we have to find letter A, value of m, B, total number of times the die was rolled. Then C, here, probability of obtaining an even number. So these are the questions that we've got to solve on this very question here. So let me get this off while we solve. Thank you, Holy Spirit. All right, so here, now the next question here is the value of m, right? Now, here, this is a question not on statistics, but on probability. A specific die, numbering 1, 2, 3, 4, 5, 6, was rolled in a number of times, which was not given. If the number of times it was rolled was given, then you'd have easily added up all these things equal to that same number of times. All right, so that's why they omitted one of the variables and put m there, such that it would demand us to find it. 1 was thrown 5 times. 2 was thrown m number of times, was hidden. 3 was thrown 55 times. 4 was thrown 45 times, and like that and like that. So the first thing we do is the probability of obtaining a 2 was given us as 0.15. That tells you that probability of obtaining a 2, okay, in probability is simply the number of times 2 was obtained over total sample space. All right, now take your time to digest this. Probability of any occurrence of any event means the number of times that event will occur over the total number of times, the total number of the sample space of the whole event. All right, so here the probability of obtaining 2 already has been given us as 0.15. So I can immerse that here. Okay, then number of times that m was thrown was hidden, m. Total sample space means you add them, the number of times the whole experiment took place. That is 5 plus m plus 55. So let's go 5 plus 55. That's 60. 60 plus 40 here. That's 100. Okay, 100 plus 70. That's 170. 170 plus m. That's 170 plus m. Notice I didn't have it. You can't add 170 plus m and say 170 m. That's not addition. That's simply multiplication. Okay, that's simply multiplication. Let me have that. All right. All right, so I'll get the full questions to them. I'll get the full question for those who need the full question. All right, so moving further here, we've got that to be, you can multiply m times 1, m, equal to 0.15, all multiplied by 170 plus m. Now, we've got this to open the bracket. So here, let me work with the calculator to avoid unnecessary error. Times 170, we've got that to be 25.5 plus 0.15 m. So what's the next thing we do? Notice we have these two variables very, very alike. So collect them. We have m minus 0.15 m equal to 25.5. So here we've got that to be, this is the coefficient there is 1. So 1 minus this. Okay, so 1 minus 0.15. We've got that to be 0.85 m. Okay, I'm sure we understand what I'm doing there. All equal to 25.5. So how do we get m very last? You divide both sides by 0.85. Quite interesting and direct. So m equal to 25.5 to divide 0.85. So we've got that to be 30. So that means the number here, the variable m here, was hidden, but actually the number there is supposed to be 30. So that means 2 was thrown 30 times. So we're able to find it. The next question tells us to find the total number of times the die was rolled. Now, who will do that for us? I would expect that right there in the comment section. All right, so notice we have this to be this already. So you can find the total number of the times the die was thrown by simply adding them now, knowing that the m has just been gotten as 30. Okay, all right. Knowing that m is just 30, so we've got 5 plus this. Okay, let's just go. Since we have the other ones to be 170, then m alone has just gotten as 30. That gives us 200 times. So this is also what? The number of times the die was thrown is 200 times. These are simple questions. So let me put it down. B. total number of times the die was thrown equal to 170 plus 30. That's 200 times. Okay, that's the answer for that B. All right. Okay, somebody's asking how we got 0.85. How we got 0.85? 0.85 was gotten from here. And let me get back to this equation here. M equal to, I began by opening this bracket here. 0.15 times 170 gave me 25.5. Then 0.15 times M gave me 0.15 M. Then from there, I collected like terms, knowing fully where this one has variable M. I brought them together. So this is a signature of what? A sign of positive sign. It crosses to become negative. Okay, so I've got M minus 0.15 M equals 25.5. Then what I did here was, now imagine you have something like this, 3M minus 2M. How would you have subtracted it? You would have only subtracted the coefficient. That is 3 minus 2. 3 minus 2 is what? 1. That gives you 1M. Or better, so you simply put as what? M. All right, so the same thing applies here. The coefficient there is actually 1. So you're subtracting 1 minus 0.15. That gave us 0.85. Okay, so if you actually got it, please attest that you got it. All right, thank you for your questions. We appreciate. All right, so we appreciate your observations and your questions at any time. Okay, all right, so here we've got the number of times the die was thrown. Move on to the last question. That's C, the probability of obtaining an even number. Now notice the English word there, not the probability of obtaining two even numbers, and that is one even number. Meanwhile, we have three different even numbers there. The even number can either be 2, or it can also be 4, or it could be 6. We are not asked to pick the three of them. Notice here, an even number. So that means either of the three was the even number they are talking about. So this is how to solve it. You say probability of picking an even number equal to probability of picking a 2, or use the word or. Probability of picking the next even number can be 4, or probability of picking a 6. Okay, that's how to lay the premises. All right, so knowing that in probability, or means addition sign, and means multiplication sign, and this also applies to permutation and combination. All right, now here, probability of obtaining a 2 is already giving us here 0.15, or plus probability of obtaining a 4. How do you obtain a 4? Number of times of 4, that's 45, over total sample, that is 200, okay, plus obtaining a 6 also is the number of times 6 was thrown over total sample space, 200. So we've got that to be the final answer. So now let me work that exactly on the calculator. So we have all right, so here I have the very first one, 0.15. Let me divide this also. 45 divided by 200. We have it as 0.225. Then the very last one, 40 divided by 200. We've got it to be 0.2. So finally, we add them up together. So 0.2 plus 0.225, okay, added with 0.15. So we've got that to be altogether 0.575, okay, as the probability of obtaining an even number. Okay, that's all about the question here. Now, moving on to the next question. Do you have any observation or question there? All right. So I want to believe they are all getting it. Okay, all right, so we've got you covered here. You have no reason to fidget in the course of your exams tomorrow. Any question whatsoever, okay, that is related to this, please just find a way to get them across to us. I would sort them and get the answers back to you. All right, if not live right here, I will do that. However, it will be solved back to you. All right, or via the WhatsApp. So I'll get the WhatsApp number on the comment section. You get that shortly now. Then you can get your questions across to us. Now, moving on to the next question, it's getting deeper and deeper. Permit me to solve this very one on the question first. Okay, I'm sure somebody's anticipating. What question has he got to right there? Let him solve it first. So let's get this solved to first. Now, then we'll move on to the others that we've got for you. All right, so here, okay, let me get this off the board. Okay, I should write it for them. Okay, I'm getting your feedbacks. So I will get the WhatsApp number right on the board for you. Here. Okay, here. WhatsApp 136498639. All right, so we would expect your question. So now let's get this question solved right away. The question here is on bearing and distance. It's on bearing and distance. Now, very interesting rather, or however, interestingly. Okay, now here let's read. Two ships leaves a harbor Q at the same time. One sails at a speed of 5 kilometers per hour on a bearing of 049. Notice this bearing. The other sails at a speed of 9 kilometers per hour on a bearing of 319. Notice this bearing also. The two ships stop at point X and Y respectively on the sea after 2 hours. Then here, draw a diagram to illustrate it. Calculate the distance between X and Y. Calculate the bearing of X from Y. Correct to the nearest degree. Now, how do you go about it? Now, notice that the two ships left the harbor Q at the same time. All right. Now, the question is not clear. I think it's the network. That's why I read the question so that they can get it. Even from the voice, you could get it. Perhaps I read it again. Okay, let me read it again so that you can get it. Whatever is not clear, you can hear me say it. Two ships leaves a harbor Q at the same time. One sails at a speed of 5 kilometers per hour on a bearing of 049 degrees. The other sails at a speed of 9 kilometers per hour on a bearing of 319 degrees. The two ships stop at point X and Y respectively on the sea after 2 hours. Question number 1, letter A rather. Draw a diagram to illustrate it. Question number BI, or letter BI rather. Calculate the distance between X and Y, correct to the nearest kilometer. Then BII, bearing of X and Y, bearing of X from Y, correct to the nearest degree. All right, so I want to believe that person actually got the question. Okay, is there a positive signal from that person? Okay, all right. Now, moving further, both ships left the harbor Q at the same time. Now, do this thing. If I put the Q here, do I know the direction the two ships will eventually go? They may decide to go this way. So rather than having to clean again, so it's always very good. The first point you want to begin with should be placed at the center of your book, so that however direction it goes, then you can be certain. Or you may have the rough idea first, then knowing a rough idea of how or the direction it may go, then you can actually take the best position for it. Maybe I should do that to conserve space in your exams tomorrow. All right, now let me see here. One of them goes 49. 49, I'll clean this off later, 49. The other goes 319. 319, 270, okay, this way. All right, so that means that I can have this harbor Q here, knowing that both ships are going this way. So let me have that here now. Okay, so let me have the harbor Q here, knowing fully well that the two ships went this way. I just checked that now. All right, so now let me begin. One sails at a speed of 5 kilometers per hour on a bearing of 049. In bearing and distance, we've got two kinds of bearing. Is there a question like that? Okay, I would show them. All right. Now, here, this is the harbor Q. the place where the two ships sailed from. Now let me teach you something here. Here, these are cardinal. From here to here is 90 degrees, in between another 90, another 90, another 90, making it all together 360, right? Now let's proceed. Since we have the first ship to sail 049 or 049 rather, 049, we always begin bearing from the North Pole in the clockwise direction. Clockwise direction. Notice this point. I begin again. It begins from here, clockwise, not anti-clockwise direction. So 049 will be within the first quadrant here. So I can have here as 49 degrees. Then here, it goes to as much, to any length as we can assume. Okay? To any length as I can have. The one of the sheep here, we have them labeled here, respectively, okay, X. X. Then the other sailed on a bearing of 319. I want to believe somebody is getting it. The other sailed on a bearing of 319. So let me get bearing of 319 also from here, knowing fully well that your bearing will still begin from this zero in the same direction. Now, rather than having to rule the line from here and crossing these ones to make it rough, just go this way. From here, you're searching for 319, right? From here, you have gotten here is 90. You have not even gotten to your answer yet. You are still heading for 319. You get what I'm talking about there? So from here to here is 90. If I've got to come here again, 180. If I've got to come here again, 270. Let me ask you a question. If I stop here, have I arrived at 319? No. Then on getting to 270, how many more angles do you think I need to arrive at the 319 from this 270? So I simply say 319 plus 270. So I've got that to be 9. This is 31. This is 1 again. 4. Okay. I've got that to be 49. Okay. I want to read that's correct there. 49, right? Okay. So now that means that on getting to 270, I need 49 more to arrive at the 319. So I will just take it up. So this is simply giving me 49. I want to believe you got how I got this 49 degrees here. Okay. Now, this very one here, let me make it. Don't mind my. All right. To a point Y. To a point Y. Now, let me get something here. The first ship was moving at the speed of 5 kilometers per hour. All ended, the journey was observed for altogether 2 hours. For 2 hours. Let me explain something to a layman. If I've got speed to be 5 kilometers per hour, it means, now, however you've been a science student or not, now just get this straight from here. 5 kilometers per hour means at every 1 hour, the ship covers 5 kilometers. Every 1 hour, it covers 5 kilometers. How many kilometers do you think the same ship would have covered in 2 hours? 10. If 5 kilometers covered in 1 hour, then altogether in the 2 hours of evaluation, the ship must have covered 10 kilometers. So that means that here will be put as 10 kilometers. Notice the topic here is bearing and distance, not speed and distance. And so we don't work with speed here, we work with distance. All right, we work with distance. So I've been able to convert the speed to distance here. Then the other ship that was traveling at 9 kilometers per hour, after 2 hours or so of evaluation, it must have traveled how many kilometers right there? 18. I'm sure somebody's getting that already. 18. So that means that here is 18 kilometers. Then what does that mean? It means that this side is quite longer than this side here. So I can shorten this one here. I could shorten this one here by virtue of the side difference. Okay, so that I join the two sides together. Join two sides together. Then here has just been gotten as what? X. We're told that the first ship arrived at X, the second ship arrived at Y. Now this is the place there. It said the two ships stopped at point X and Y respectively. Meaning the first ship was what headed for X, the second ship was what headed for Y. Then we have to find the distance. Okay, sorry. The first question says draw a diagram to illustrate, which we've done here. So this is letter A has been done already. Then letter B, Roman figure 1 says calculate the distance between x and y. So let me put that here. Distance xy. Now, this will take us through trigonometry. How do I mean? And let's evaluate something here. Notice initially I said each of the quadrants here are perpendicular angles. 90-90. So that tells us that if here to here is 49, what do you think will be here, the other angle? If I take 49 from 90, I will have this one here. And that's going to be what? 41. That's going to be 41. All right? Okay. Now, if here is 41, and I'm just going there to be 49, then what do you think is the whole angle together here? I simply say 41 plus 49, and that's got me 90 degrees. So that means the triangle in question here is a right angle triangle. Now, I will work with sine rule and cosine rule. Perhaps we may as well use Pythagoras theorem or Socrates here as well to get the xy. Okay, I could use any of them. Okay, let me use both of them. Since we notice a right angle triangle, why? It is not a must that it is drawn this way that you conclude as a right angle triangle. No. As long as one of its angles is 90 degrees, that makes it a right angle triangle. Is that okay? All right. So now, since we agree with that, to find the xy, I can work with Pythagoras theorem. I can also rewrite the triangle this way. Okay, friendly to what you know. This is the 90. This is the xy we have to find. Okay, all right. This is one of the sides, 10 kilometers. This is the longer side, 18 kilometers. Then I can find my xy. Using Pythagoras theorem. I can say that xy squared equal to 18 squared plus 10 squared. So that gives us xy squared. 18 squared, we've got that to be 18 times 18. That's 324. 324 plus 100. So we've got xy squared equal to 424. So xy equal to square root of 424. So what do we have there? Square root of answer. We got that to be 18 kilometers. Got that to be 18 kilometers. All right. I want to believe we did exactly. Okay. So here 18, 324. Sorry, let me have to reconfirm that. 324 plus 100. Okay. Square root of answer. Square root of 424. Let's I think he went for. So square root of 424 gives me 20.59 kilometers. 20.59 kilometers. I think we said to the nearest kilometer, right? Nearest. So xy approximately to the nearest kilometer gives me. Now this 5 can add up 1. So this so that becomes 21. So to the nearest kilometers, the xy has been gotten as what? 21 kilometers. So we are done with the bi. Then move on to the bii. That is okay. All right. So let me use the cosine rule too, like somebody demanded for right there. All right. So I've done this. So let's notice or take note of the answer. So this other method should also give us the same answer, however the method you want to use. Now let me use sine rule. So here,
20.6 also correct.
20.6.
No, 20.59.
Okay, 20.6. This is correct, but not exactly to the next whole number. This is just to one decimal place. Okay, but if you have to do it to next kilometers, it should be 21, not 20.6. This is correct if and only if you have to do it to one decimal place. Is that correct? All right. Now let me use the other method. That is cosine rule. Cosine rule here. Notice we are working with 3 sides here. 18 kilometers is given. Xy is asked us to find. Then 10 kilometers is given us, and we're given an angle 90. Notice that anytime you're working in a triangle where 3 sides are involved, 3 sides are involved, including what you have to find. I mean 3 sides are involved and 1 angle. Then you use your cosine rule. How do you use your cosine rule? Now, notice I said when 1 angle is involved. So the angle involved may be the angle here. The angle involved may be the angle here. It may be the angle here. So it is actually the angle here anyway. So since it is the angle here, so I have to begin with the side facing that only angle. If the angle was here, I would have begun with this. Is it clear? If the angle was here, I would have begun with this side. But since the angle is here, I would begin with this. So that means I would write as though Pythagoras theorem. Starting from here, I will say xy squared as though Pythagoras theorem. Very easy to understand. Equal to 10 squared plus 18 squared. Okay, doesn't it look like Pythagoras? It looks right. Then you continue, you say minus 2 multiply this, whatever the two sides you have here, you've got them to multiply here. So you have 10 times 18, then cos the only angle that you have, which the only angle here is 90 degrees. So we have xy squared, 10 squared gives us 100, 18 squared gives us 324, minus, this is 180 times 2. Okay, 360, then cos 90 degrees. Okay, all right. So now you know that cos 90 is nothing but 0. Cos 90 is 0. Okay, let's confirm that. Cos 90 is 0. So that means that 0 multiplied by 360 is gone. So we have xy squared equal to, back to this one here, we've got it as 424. And that gives us the xy square root of 424, and that gives us exactly what we've got the other time. Okay, 20.5, I think 20.5. Okay, let me do it again. Square root of 424, 20.59. All right, so to nearest kilometer, approximately, got that to be 21 kilometers. Notice we got the same answer using the cosine rule and the Pythagoras theorem. So you can decide whichever one you are good with. All right, so moving on to the very last question here, and that's the bearing. That's the bearing. That's the bearing of x from y, correct to the nearest degree. Now, let me be meticulous in this aspect. Let me be intentional. So please just come with me. The bearing of x from that place tagged as from is a place of reference. Bearing of x from here. Okay, so that means the angle needs to be measured from here. Bearing of x from here. Now, bearing, notice I said the other time, I began the bearing from the 0 degree side, from the 0 degree view to the line going to that same point. So since the 0 end here is this here, so I have to go in this direction, and I will stop as soon as it gets to the line going to that same x. So the whole of this angle that I've marked is equally the bearing they are demanding for here as the bearing of x from the y. Right, let me take it the other way around. If we were asked to find the bearing of y from here, I would have taken reference point here and mark from 0. While I go, I wouldn't stop here because this is not the place, this is not the line going to the x, to the y. So I have to go until it gets to that same line, getting to the y. So the angle I marked here, let me say it again, it is the bearing of the y from x. Meanwhile, the angle I marked here is now the bearing of x from here. So we are not asked to find this one. Let me erase it. Okay, let me take it off. All right, but rather we have to do this from here. So how do you go about getting this angle here? There is never a rule, okay, or a way to get an angle that is outside a triangle. No. So to have found this angle is to also find this angle within. Knowing that if you are able to find this angle within, then we'll be able to get through to get this required angle. This is the exact angle we have to find, not even this one. But we couldn't have found this, okay, without finding this angle inside. That's the point. So let me call this one alpha, which is the main angle of the main angle of contention. All right. Now, how do I get the theta? First, now here, notice here, let me erase this one. Let me erase this one. I just got here now, this side to be 21 kilometers, right? Now, I have a sine rule. Sine rule applies to a triangle where two sides and two angles are involved. Let me take that again. Sine rule applies to triangle where two sides and two triangles are involved. Now, since I'm to find this angle here, so let me pick these two angles and the two angles involved. While I identify among these three sides, two of them that are suitable to these two angles. I'm sure somebody is getting what I'm talking about. So, to this angle, I shall pick this side because this is the side facing this angle here. Now, I'm working on this angle also. I shall also pick this side. Since this is the side facing this angle, I have no business whatsoever with this side because this angle here is not involved. I'm sure you can get that. So here we're working with two sides, two angles rather, and two sides. Since the two angles are this, okay, what will be the required two sides or the expected two sides? There's going to be this side and this side. I have no business with this, okay, whatsoever, as long as this question is concerned. Now, here, recall sine rule to be equal to sine rule equal to, I say A over sine A. I'm going to explain this. Equal to B over sine B. I can continue, okay, I can continue to any length over sine C. I may even say D over sine D. I can even say E over sine E. Permit me to stop there, okay? So that means that if I'm going to take any side, this, the small case here indicates the side, while the big case here represents the angle. So it means that if I'm taking a side A, it must be over sine of the angle facing that same side A. That's what it means. So literally, you don't need this alphabet whatsoever. You only just need the interpretation of that rule. So here, I'm taking the side 10. So I have 10 over sine theta equal to, now I'm taking the side 21. 21 over sine 90. Okay, then over sine 90. Then here we have, let me cross multiply. So I have 10 sine 90 equal to 21 sine theta. Okay, now I'm looking for theta. So let me get 21. Let me get 21 out of here. The variables have a 21. Okay, then 10 sine 90. Sine 90, like I said the other time, is 1. Okay, sine 90 is 1. So I have sine theta equal to 10 sine 90. Sine 90, like I said, is 1. So 10 times 1 gives us 10 over 21. So we've got sine theta to be equal to, let me divide that, 10 divided by 21. So we've got that to be 0.476. Then invariably, theta becomes sine inverse of 0.476. So phi becomes second function sine answer. Since I have it on the screen, okay, the calculator, I've got that to be 28.4. 28.4. Now, this is not our answer. I just got this angle here to be 28.4. But what I'm asked to find exactly is actually this angle alpha. So knowing theta to be this, how would we be able to find the alpha? What's the technical way to be able to find the alpha? Now, let me also get this here. Now, just go with me, please. Now, there's what we call alternate angle. Now, let's get that done here. Okay, this side being parallel, if I trace this up, this side and this side, they are parallel sides. Okay, now go with me, please. This way, this way. So if here is 41, it means that here too shall be 41. What do we call that in mathematics? We call that alternate angles. So here's 41. So that means that this angle 41 and this angle theta and this alpha that I don't know are all on a straight line. True or false? Okay, 41 plus this, all on a straight line. Okay, so I can say that my alpha, any observation there?
Yes, all is asking if the sign rule can be the inverse of sign capital A over small a because it's
yes.
capital B over small b.
Yes, it can be done. You are still heading for the same thing. What the person is asking is this: if you can actually have sine A over A equal to sine B over B, of course it goes. That's mathematics. Okay, that's still mathematics. We are still on this very same page. Permit me, let me refill that marker. Okay, while they take their time to digest what we've got right there on the board. Okay. All right. So here we have. So we've been able to get that. So I can finally now say, since I have this 41, together with this theta that just been gotten, together with my alpha, all to be on the straight line, I can say, therefore, that the alpha plus 28.4 plus 41 all equal to 180. Quite easy, direct principle. Any question there? All right, so I have alpha equal to 180. Take all of this to the other side. It becomes minus 28.4, then minus 41. We've got alpha finally, okay, to fetch us this 180 minus 28.4, then minus 41. We've got that to be 110.6, 110.6 degrees. But we have to make it to no, this angle is straight line, not angle at the point. Okay, this is a straight line. Now this is straight line I'm talking about. All of these angles, they are on a straight line. All right, so their summation is bound to be 180. All right, so here we are asked to do so to the nearest degree. So nearest degree means that approximately to the next whole number, 6 can add 1 up to become this one to become what? 1 degrees. So we've been able to find all of these questions very direct and simple. Okay, now we move on to just 2 more questions, then we round it up there. Just 2 more questions. I want to believe it's worth it that you're there anyway. And do well to share this very class. Okay, this ongoing class with your friends who will be having exams tomorrow. They will be glad. They would appreciate it. Okay, all right, so I thought we got a question there. Just do well to share the class, please, to your classmates or your colleagues who will be writing the exams. How did I eliminate the sin 90? Okay, sin 90 on the calculator gave us 1. It wasn't eliminated, it was 1. So sin 90 being 1 times 10 gave us 10 over 21. That's why we've got it there. Okay, 10 over 21. So we didn't eliminate it, it gave us 1. Now let's solve more questions, just 2 more questions, then we'll round it up there. Now this one here says, we're given, this is on financial what problem? Okay, what problem involving finances? Okay, all right. I'm sure we are anticipating for it. Then we close up with the statistics that you cannot escape from. You can't dodge from it anyway. Okay, so I think I'm done with this question. Now here, that's question number. Now permit me to just put in the values here. The question says a woman, that's question number 8. A woman spent 1/4 of her monthly income on food. When you have questions like this, the first question you ask yourself is, how much is the income first? That you are being told the fraction of the income to be spent on something else. So on that note, since we have to find our monthly income too, you simply say, let our monthly income first be any variable of your choice. So I'm deciding to work with X here. Okay, I should read the question to them. Okay, a woman spent 1/4 of her monthly income on food, 1/3 on open market, and 2/5 of the remainder on mechanic workshop. If she saved the remaining 225,000 naira, find Roman figure 1, her monthly income. Roman figure 2, the amount she spent on open market. That's the question. So now let me make a monthly income first to be a variable of my choice. I've decided to work with X here. You may decide to work with P. You may decide to work with Y. Now here, now to go on, we're told 1/4 of our monthly income on food. So that means the amount she spent on food was 1/4 of the value of X. 1/4 of the income. That gives us X/4 on food. Then the other expenditure that she made, that open market. Open market. On open market, she spent 1/3. 1/3 on open market. That is 1/3 of the same income. Okay, 1/3 of the same X. So we've got that to be X/3 on open market, and 2/5 of the remainder. Okay, of the remainder on mechanic workshop. Of the remainder. Now, mechanic. Now, this is a very quite technical question. Mechanic workshop. Now, here we're not just told 2/5 of the income. We're told 2/5 of the remainder. What does that mean? If the monthly income was X, and she has spent this out of it, and she has spent this also out of it, then the remainder was the 2/5 of the remainder is exactly what they're talking about. Let's digest that. We were not told 2/5 of the income. We would have done something like this as usual, 2/5 times the X, but it won't work this very time. This is not correct here, because we're not told 2/5 of the income. We're told 2/5 of the remainder. Meaning, and let's get the remainder first of all. Let's get the remainder. So let me get the remainder. Let me say remainder. Okay, will be the initial value, which was X, minus the amount she spent on food, minus the amount she spent on open market. Then will give us the remainder. Isn't that interesting? So I'm going to be over 1. So the LCM here gives me what? 12. Okay, here I've got, okay, let me do that here. So I've got it to be 12. So I've got it here to be 12x minus 4 in 12 is 3. 3 times x, 3x, minus 3 in 12, that's 4. 4 times x, 4x. So I've got that to be finally 12x minus 3x, that's 9x. 9x minus 4x, that's what? 5x. So I've got it to be 5x over 12. So now this is the remainder. So this very time is she spent on mechanic workshop. On mechanic workshop, okay, she spent 2/5. What fraction? Let me take it again. Sorry, I'm having to get the fraction of what was mentioned. Okay, she's got to spend 2/5 of the remainder. This is the remainder. Notice that. So she spent 2/5 of the remainder, that is of 5x over 12. Okay, here it gives us 5, cancel out this 5, and 2 here gives us 6. So it's equally telling us x over 6. So she has been able to spend x over 6, okay, on the mechanic workshop, which invariably interpret to say 1/6 of the income. But they didn't tell us that way. They told us 2/5 or 2/5 of the remainder. So it's equally telling us the same thing anyway. Now, while she saved the rest of the remaining 200, and she saved the remaining 225,000, then find our monthly income. How do you go about it? Okay, how do you go about it? Now we have been able to see our budget. Okay, now she spent some fraction on food, she spent some on open market, she spent some on mechanic workshop, and she saved the rest. This. So that tells us that if I'm able to add all of our expenditure together and the one she saved, it should give me a monthly income. That's exactly what it means. So I can say that X, our monthly income, equal to our amount she spent on food, X over 4, plus that which she spent on open market, X over 3, plus that which she spent on mechanic workshop, X over 6, plus the remainder that she saved, 225,000 there, should add up to give us this value of X. Then we get the value of X using simple algebraic expression. So here, over 1, X equal to, what's the LCM here? I've got the LCM to be 12. 4 in 12, 3. 3 times X, 3X. 3 in 12, 4. 4 times X, 4X. 6 in 12, 2. 2 times X, 2X. Any question from there?
Yes, sir, please. I'm a bit confused on the mechanic part. Is it that what she has left is x over 6.
Okay, I will take that. Let the person just be patient. I will get back there now. All right, 6 in 12. That's what 2 times x, 2x plus 1 in 12. 12 times 2250. Now let me get that. Then I will get back to the question that we've got there on the comment section. Okay, we're simply here for you tonight. Okay, so times 12 times 225,000. So that's 2,700,000. 2,700,000. All right, so let me get the question again. Now that the mechanic for this segment, right? Now, the amount she spent on mechanic workshop wasn't told us directly. We were told that she spent 2/5 of what she had left after she had spent the food and the open market out from her salary. Okay. Now, she had X income, X naira income. She has spent X/4 on food. So take that out. She had also spent X/3 on open market. Take that out. She should have something left after spending these two. All right. Then what she has left, or what she had left, was what we're told that she spent 2/5 of that very amount she had left. So which I went for that to find what she had left first by subtracting her monthly income first of all from the amount she spent on food and the amount she spent on open market. So what I have from this subtraction, I got it to be this, which indicates that this is what she had left after she has spent on food and open market. Then she now spent 2/5 of this remainder. That's what I did here. 2/5 of the 5x over 12. I'm sure the person can get it now. All right. So if you can get it, please, I need your positive response. Just give me a thumbs up that you actually got it. All right. So here I've been able to do this. This cancel out this. 2 in 6 gives me 2 into that gives me 6. So x over 6 is what she eventually spent on the mechanic. Is there any positive response from that person? Not yet.
Yes, other person said, please, why did you subtract the amount she spent on food from the one she spent on the open market?
Because we're told that she spent 2/5 of the remainder after she has spent food and open market out. Remainder means that when this two has been spent out from her income, what she has left is what I call the remainder. Then she didn't spend all of those things on the mechanic. She now spent 2/5 of what she had left. That's what I mean, and that's what I've just done here. Huh? Is there any issue there? Questions?
So the first person has already replied that you understood.
Thompson, okay, that's great. All right. Any other observation there? The clarity?
It's clear. Academic, it's clear.
I want to believe you can get the picture right there. It's clear enough. Please, I need a response if it's clear enough, please. Every one of you, please type yes if it's clear. However you're saying it there, just give us a comment there. Okay, so that we will not just be working without you seeing it. If not answered. Okay, I would appreciate your response. Please, if you're actually seeing this thing very clear, please indicate. If it's not clear enough, please indicate also so we can adjust, adequately.
Some said yes, the other person said no, it's not clear. Some said not clear enough. Some said yes, it's clear.
How many clarity, how many not clear? If the clarity is more than not clear, I proceed.
About 2 is not clear. Only 2 people indicated that is not clear. Okay, 3. 2 people indicated that is not clear.
Okay, obviously from there, is it not clear from there?
No, it's not clear. It's a bit clear.
I think it should be the network. Because I should take my time to solve it. Solving it without them seeing it is just a waste of time. It's a waste of time. Okay.
Someone said, but I hope the amount of food should be added to the open market, not subtract. That you should add the food and open market together, then subtract it.
Yes, however, if you do it that way, you're still getting the same thing. You could add it together and subtract. You're still heading for the same answer. All right, so is there any positive change there?
No. I think it's the
Okay, maybe you can get that. You switch on the. You can get that done. All right. So now to proceed from here, I think it's fair enough.
one side is clear now.
Okay. All right. Thank you very much for your response. I appreciate you all. I wish you all the best in your exams tomorrow. Okay. So 3x plus 4x, that gives us 7x, plus 2x, that gives us 9x. 9x plus 2,700,000. Okay, over 12. The next thing we do here is we cross multiply. 12 times x, got that to be 12x equal to 9x plus 2,700,000. Then from here you collect like terms. So you have 12x. Let me bring 9x to here. It becomes minus 9x. Okay, equal to 2,700,000. Okay, I'm sure they can see it better now, right? Okay. I think you, okay. All right, so from here, 12x minus 9x gives us what? 3x equal to 2,700,000. Then we've got finally to divide both sides by 3. Divide both sides by 3. 3 cancel out, so we have x equal to 3 into 27 is 9. So got that to be 900,000 naira is our monthly income. So we've been able to solve the very first question, our monthly income. The next question is how much is spent on an open market? On the open market. Notice that on the open market, we're told that she spent, I think, let me get that fraction of what she spent on the open market. On the open market, 1/3. 1/3 of our income. So now we've got the income to be 900,000. So 900,000 divided by 3, that gives us 300,000. So she spent 300,000 on the open market. Okay. Now let's go to the B part of this, and we solve the very last question on statistics, and we draw the curtain there. We won't be able to do the construction because of the constraint of the nature of the board we've got here. Okay, except the person can actually chat me up privately. I can do a video chat with that person, you know, not on the board but on a very small paper. Okay, I can do that. All right, now we will attend to your questions right away. The B part of that, the B part here, we're given that the third and ninth term. Okay, let me read the question to us. The third and ninth term of an arithmetic progression AP are 4m minus 2n and 2m minus 8n respectively. Express the common ratio in terms of m and n. Now let me take that. The third term was given as 4m minus 2n. Also, the ninth term, that's T9, is given as 2m minus 8n. Okay, we have to find the common difference D in terms of n and m. How do you go about it? Notice the sequence here. We're told it is an arithmetic sequence, meaning that, so now let's get the arithmetic sequence Tn formula. We've got that to be a plus n minus 1, close the bracket of D. Now, if you're working with the arithmetic progression, we've got that to be this. While some of the nth term, Sn, is equal to n over 2, open bracket 2a, plus n minus 1, close bracket D. Here, if you have to find the sum of the first n terms, so for AP, if you have to find the nth term itself, okay? Now, we have to find the common difference here. How do we find the common difference? Now, let me take us through the very, very short route. The third term in an AP, T3 means n will be 3. So I'll say A, and let me get this, T3 equal to, that means n is 3, right? So that's going to be 3 minus 1. That gives us what? 2. That will be A plus 2D. Excuse me. So T3 is going to be what? A plus 2D, right? And now, T9 is going to be what? A plus 8D. All right. Now, let's go by that short route. T3, let's go. A plus 2D, I'm sure you can get that, equal to 4m minus 2n. And let's go by this too. T9, that will give us a plus 8d. Okay, equal to 2m minus 8n. Quite easy and direct. Then what's the next thing to do? Okay, now let me take this out. Now I have to find the common difference d. Now let me do this. Okay, let me subtract both the equation. Let me subtract both the equation. Let me subtract both the equation. Use it like elimination method. A cancel out a, it goes off. Then I've got here 2d minus 8d, all right, equal to 4m minus 2m. Okay, now let's go again. Okay, or let me put it together. 4m minus 2n. 4m minus 2n together here, minus all of this together as well. 2m minus 8n. I want to believe you can understand what I'm doing there. Okay, let me take it again. I subtracted the two equations so that a and a goes off. Then I have 2d minus 8d. I've got that written out here. Then all of these minus all of this as well. I've got that here. So I can have 2d minus 8d gives me minus 6d equal to, now opening this bracket gives me 4m minus 2n. Open this as well, minus opening this gives us 2m, minus times minus gives me what? Positive 8n, right? Now I think I can take off this negative sign, the bracket I mean. Then I've got minus 6d equal to 4m and 2m I like times. So 4m minus 2m gives me 2m. And of course, minus 2n plus 8n, okay, gives me plus 6n. All right. So finally, okay, thank you very much. I appreciate it. Thank you. Sorry, I just have to hydrate myself. All right, thank you. Now, so from here we've got minus 6d equal to, so minus 6 equal to m plus 6n. We have to make d in terms of m and n. So finally, I divide both sides by minus 6. It leaves here, so we've got d alone to be equal to 2m plus 6n all over minus 6. Now, some may bring this minus sign upward there to become minus open bracket 2m plus 6n, leaving the 6 alone beneath, such that I can reopen it to become, let me reopen it. Okay, that gives me here minus 2m minus 6n over 6. So I've been able to find this. Okay, some may even do something like this. I can simplify further. Since I have 2 to be common here, so I can say minus 2 open bracket m, okay, open bracket m plus n, okay, my 3 I mean 3n, okay, all over 6, such that the 2 here cancel out this one to become 3. I finally now have minus open bracket m plus 3n all over 3. Okay, final answer, you may leave it this way. Some may stop this way. Okay, you are still heading for, you are still on the very, very correct page. Okay, from what point? And once the person indicated, we will get back to that person. Now let's move on to the next question. Now the very last question for today. The very last question for today, that's going to be on statistics. On statistics, so please stay connected. This is the very, very old lessons of the math class. You can't escape statistics in your exams. In any mathematics exams, be Neco, be WAHEC, knowing fully well that you're writing the Neco exams tomorrow. So you just got brought to learn statistics. All right? You just got brought to learn it. All right? So now we're moving to the last question. We are rounding up gradually. We're rounding up in a moment. So here we have, okay, I have a question this way. Okay, let me put it here. Statistics here, we have the class mark, we have the frequency, we have the class interval 0 to 9. Okay, come in.
So when you start, if it is from minus 1n, all you just like one of the one beside the last one. I think make sure brush that when you are eating.
90 to 99. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. The frequencies are 7, 11, 17, 20, 29, 34, 30, 25, 21, and 6. Now, the question here says we have to construct a cumulative frequency table for the data. Construct a cumulative frequency table for the data, as we've got on the board there. The next question says, draw a cumulative frequency curve, OGIF, for the data. And the last question says, using the graph, estimate the median score, lowest mark for distinction if 5% of the candidates made the distinction. All right. Okay, so how do you go about this question here? Now, very interesting and direct. So here, what we need to do, so let me take this off here, so I can solve it on this very part here.
Once the change is that would be like the way I want to wait for that.
All right. Okay, so here, now what we need to do, cumulative frequency curve. Sorry, cumulative frequency table. This is a table first. So now how do you go about the table? Now, here I would, okay, let me rule it this way. The first one is usually the class interval. Class interval. The class intervals are this: 0 to 9, okay, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, then 90 to 99. Okay, then the next one would definitely be the frequency. Okay, had it been we're working with tally system here, tally becomes the next one, while frequency always come up after tally system. But here it does not involve tally. So move on to the frequency directly. Here, 7, 11, 17, 20, 29, 34, 30, 25, 21, and 6. Now, the next thing also is what we call the class mark. The class mark. Okay? The class mark. How do you get the class mark? The class mark is denoted as what? X. How do you get the class mark? It's simply an average of the class interval. How do you get it? You have the 0 to 9, you divide it by 2. 0 plus 9, that gives us 9. 9 divided by 2 gives us 4.5. 4.5. And I've got to do the other one too. Add 10 to 19 divided by 2. That gives us 14.5. Okay? Now let's get that. 10 plus 19 divided by 2. 14.5. Now, instead of having to run this again, just notice the difference between this and this. Notice them to be 10. Then just continue that multiple of 10. Then here you have 24.5 plus 10, right? Plus 10 again, 34.5. Very simple. Plus 10, plus 10, plus 10, plus 10, plus 10, plus 10. So I've been able to do the class mark. The next thing that should follow is the class boundary. Okay, we have class boundary. Class boundary. Okay, how do you go about the class boundary? Notice my ruling, quite neat with my freehand sketch. Please ensure that your ruling are well ruled in the exams tomorrow. Class boundary, how do you get the class boundary? Now, it is usually said that you subtract 0.5, you add it there. Well, that is true, but it is expedient that you know the rudiment behind this thing. Now, what is the last number here? 9. What is the starting number here? 10. Tell me the difference between this 9 and this 10. 1. That is why it is not 1. You divide by 2. That gives you 0.5. That's why we often tell you that you subtract 0.5 from here, add the 0.5 to this one here. But perhaps you have the interval to be something like this, 0 to 6. And here is 8 to 14. Okay? Now here, it won't be good if you say subtract 0.5, add it here. Because the difference between this number here and this number here is 2. So in this case, you will say 2 divided by 2. Any difference you have there, you divide it by 2. So here, 2 divided by 2 gives you 1. So it is 1 you subtract here, it is 1 you add here. So the class boundary here will now be minus 1 to 5. Here it's going to give you, okay, sorry, you add it here, I mean. Subtract it from here, add it here. That's 7. Subtract 1 from here, minus 1. Add it here, 7. Subtract it from here, 7. Add it here, 15. That's why you now have it 7, 7 here. After doing the class boundary here, the upper class boundary here should always tally with the lower class boundary, the first one here. That means you're on the very correct. Let's see that here. Subtract 0.5 from here. We've got that to be minus 0.5 to 9.5. Then subtract 0.5 from here, 9.5. You can see you have the same thing here as you've got the same thing here and here. Okay, to 19.5. Okay, do the same thing here, 19.5 to, so you may just proceed from there. Whatever you have here begins from here also, 29.5 to 39.5. Let's go again. I want to believe you're making gesture, making the gesture with your mouth. All right, 49.5. Then from here, 49.5 to, all right, here. Then here you've got 69.5 to 79.5. Then here 79.5 to, then here. All right, so we've got the what is it now? The class boundaries now done. Now these are residual components of your cumulative frequency table. Residual, what I mean by residual component, I mean that however what you ask to find, these are very, very essential, that must be a component of your table. Then if you are now asked to find the median or the mean, then you may not decide either the fx with its mean or cf with its the median. However, now let's get what we've got to do here. Here we've been asked to construct an OGIF and to use the OGIF to get the median score. So we will need what we call the cumulative frequency, the CF. Okay, how do we get the CF from here? CF, how do you get the CF? CF is gotten by simply the first number, the frequency. I've got that put back here, 7. 7 here, you put it back there, then you add it with the next frequency. That's exactly what? 18. Very simple. You got it with the next frequency again, that's 35. You add it with the next frequency, that's 55. 55 plus 29 again, I've got it to be 84. Okay, 84 plus the next frequency, we've got it to be 118. All right, 118. 118 added with the next one, I've got it to be 148. I'm sure you can follow that. 148 added with the next one, I've got it to be 173. 173 with the next one, I've got it to be 194. Then 194 with 6 gives me 200. So if you want to know if you are actually on the correct page, now the last number in the CF should be equal to the sum of the frequency. That's exactly what we've got there. So if you have to sum the frequency up, you are getting but the 200. Exactly the answer here. Now the next thing is, now I haven't done that. Since we are not looking for mean, so we don't need to create an FX column. No. Or standard deviation, x bar minus x minus x bar, all of that. No. Since we are not asked to do all of those things, so I can shorten it this way now. Then we move on to the construction, the graph. Then we put on to the graph now. How do we go about the graph? Now, you will permit my construction here on the board. Okay? But I want to believe you will do that on the real graph book there. Okay? For the actual value. But you follow my demonstration. The axis, class boundary.
Okay, please repeat again because the network first.
Okay, somebody mentioned that.
Network here first. Even from the end, they said it first.
All right. Now let me take that again. Now, when if we are asked to construct OGIF, or what I call cumulative frequency curve, either of the two, either way, or either names they put it up, it's still the same thing. It is simply ask you to plot a graph of cumulative frequency on the vertical axis against class boundary on the x-axis. Now, what if you have to do histogram? Histogram is also a graph, but this very time is a graph of normal frequency against class boundary. Now, note the difference there. This is cumulative frequency against class boundary, OGIF. But if I take the cumulative frequency out and put normal frequency there, here, then the graph becomes back histogram. It becomes histogram. Okay? All right. So now get the rudiment of either of these two. But here we're working with OGIF. So it has to be cumulative frequency and class boundary. Is somebody getting that there? All right. And notice that in a standard graph, we've got 12 boxes here. 12 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12. We've got 12 boxes on the vertical axis, and on the x-axis we've got 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so now that's exactly what we've got on the standard graph. Okay, any comment from there?
Also, can you come if the network is bad?
Is it back now?
Yes.
Is the network back naturally? Is it clear for them?
Ask them to give you thumbs up.
Please, I need a positive response. I need a response if what we're doing right here on the board is very clear for you, visible for you. Please do what to indicate there.
Also about the OB. This one, that's when it got first.
Okay.
Now they say network is clear now.
It's clear now, right? Yes. All right. So let them react that they actually getting it.
It's clear now.
It's clear. All right. All right. So now OGIF, like I said, it's a graph. They will mention the word OGIF. But OGIF would interpret to you that you are asked to plot cumulative frequency against class boundary. I take that again. OGIF is a graph where cumulative frequency is plotted against class boundary. Now, what if you were asked to plot or you do a graph called a histogram? Histogram is also a graphical illustration that shows normal frequency, not cumulative frequency this time around now, against the same class boundary. All right. Now, to move on here, so I've been able to show the calibration of a standard graph to have 12 boxes on the vertical axis and 10 on the horizontal. Now, thank God we've got the class boundary to be 10 altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So I would have them put on each of them. So the very first one, 9.5. The next one, 19.5. The next one, 29.5. The next one, 39.5. The next one, 49.5. The next one, 59.5. The next one, 69.5. The next one, 79.5. Notice the way I'm writing it. I'm writing them, downward, so as not to take the space. If you are written it this way, it could have encroached the axis of the next one. So write it this way, 89.5, and of course 99.5. So we've got the maximum value to be within the range. All right. Then while we calibrate the cumulative frequency too, that's why we constructed this. The highest value is 200. Okay, it's 200. So I can do something like this: 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. If I did that way, would it work? No. So let me make it 20, therefore. So I can say 20, 40, 60, 80, 100, 120, 140, just a multiple of 2020, for the sake of this highest number 200 to be able to come within the range. So 160, okay, 180, 200. Notice we've got that here. Well, let's just calibrate everything. Let's exhaust the whole page. 220 and of course 240. Now, let me explain to us, very easy and direct. Okay? Now, on the standard graph, please, shortly after this class, just go get a graph book. Now, get the same table here and do the real graphical illustration for the OGI and get your correct answer on the comment section. I will await them. Okay, thank you. I will await them. All right, so on the standard graph, I've just told us now that we've got 12 boxes, and each of those boxes, or each of the boxes rather, okay, has other 10 tiny boxes within, meaning that if one box has a total mark of 20, then and there are 10 other tiny boxes within that space of one box, then one box within will be equal to how many boxes, how many values? You simply say the 20 divided by 10. Let me take that again. Now, between here and here, you've got 10 tiny boxes in between again, 10 tiny divisions, and the whole of the 10 gives us 20. What do you think will be equivalent to one of them? You simply say 20 divided by 10. That gives you 2. That gives you 2. That's 2, not 0.2. Okay? So that means you are counting 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. You can see. So each box within is 2, 2, 2. That's the meaning.
Repeat it again, because most of them are writing 0.2 per box.
Not 0.2. Let them correct that. Each of the box there. Let me take that again. I want to see you put the correct value on the comment section there. Now here, from 0, let me not block this. Now, from 0, this very place here, from here, down to this very place here, you've got 10 other tiny boxes in between here. Is that so? All right. Now, if that is true, and the whole of them gives us a total value of 20, if the whole of them gives us a total value of 20, what will be equivalent to each of those boxes? You simply say the 20 divided by 10. That gives us 2. That means each of the tiny boxes, each of those small boxes is now equivalent to what? 2. Now, all right. So now let's go ahead, indicating all of these things one after the other. When the cumulative frequency was 7.
Someone said something here.
Yes.
He said, sir, the difference between 0 and 9.5. And the person made a mistake, does not know how to calculate the class boundary.
Okay.
So I think it should.
All right. So the person would, okay, as the person gotten it, or I would repost this very class. I will still have to repost it, so you can visit it again to just redigest it. All right. So, all right. So expect this class to be uploaded on this same YouTube channel. All right. Now, how do we allocate this 7 here? Okay, 7, knowing fully well that each box is 2. So I've got to count 2, 4, 6. The next one is now 8. But excuse me, let me expand that thing for you. Let's assume these are the tiny boxes. 6, 8, 10, 12. These are the tiny boxes. 7 cannot be marked. 7 would have been in between here. And there is no space in between an empty box. So you cannot mark an empty space. You either count it up to 8 or you bring it down to 6. Did you get that now? That 7, you either make it up to 8 or you make it down to 7. And let me correct you on something. If you decide to make it up to 8, that means subsequently every making up like that should be made up rather than made down. Did you get that now? But if you decide to make it back to 6, then subsequently every making up like that should be made down. Okay, so now let me make it up to 8. So I'll make it up to 8. Now I've got to count 4 boxes. No, you can't count in between an empty line. A graph, you don't mark, you don't asterisk an empty line. You asterisk, the point where 2 lines meet. You asterisk here. You don't asterisk an empty space. Okay, you do not. There is no law, that supports that. You only asterisk a vertex where 2 lines meet, either here or here or here or here or here or here. Never an empty space. Is that correct? So note those things here. All right. So I've got them counted to 8. So I've got to count 4 boxes. So let me assume here. Then trace it back to 9.5. For 7, this is the class boundary, 9.5. So this 9.5 here, I've got that traced here. So I asterisk this place here. Okay, I asterisk that. All right. The next one is 18. 18. Now, 18 from 20. I think that should be 2 below 20. And 1 box is 2. So I will just go 1 box below 20. I've arrived at 18. Is that clear? So 1 box below 20 has gotten me 18. And for the cumulative difference of 18, the class boundary is what? 19.5. So I've got that trace to 19.5. I trace this one up to what I trace. So while they meet here, I asterisk it so I can clean up that line. But meanwhile, you should be doing on the real graph where those lines are there constructed for you already. All right. So the next class boundary is what? Sorry, cumulative difference is 35. This is odd number. Odd number should be counted up. I counted up this one to 8. So I should count up this one to 36. 36. So that's going to be from 40. Now, from 40, if I go 1 box below, 1 box below 40 is what? 38. I'm sure you're getting that. 1 box below 38 again, 36. So I'll rather just go 2 boxes below 40. 2 boxes below, 1, 2. So I've got 36. 2 boxes below 40, I've got for 36. Then 36 traced up to 29.5. You trace this up as well. Where they meet, you asterisk the place, you clean this off. All right. So you're getting that. Okay. All right. So here, the next value is 55. Another odd number. Please permit me to run it up again to 56. 56. Here, now let's get here from 60. If I take 1 box below, what is that? 58. Another 1 box below, 56. So that means if I go 2 boxes below 60, I've arrived at 56. 2 boxes below. Okay, trace it out here and trace it up to where they intersect, you asterisk it. Okay, all right. So and so on and so forth. That's exactly how we go. 84. 84. That's just how many boxes above 80? Okay. Is somebody getting it there? It's going to be 2 boxes above 80. 2 boxes. 1, 2. So I've got the 2 boxes above 80 here. Trace that out. Bring this up to meet each other. So where they meet, you asterisk the place there as that value. All right. The next one is 118. 118 is, now let's get this. From 120, if I go 1 box below 120, what do you think I've got there? 118. So to get this 118 is simply 1 box below 120. Okay, 1 tiny box below it. So let me trace that out. While I trace this one up here, where they meet, I'll stack the place there. Okay, I'm having to ensure more accurate value in spite of my, not being accurate on the graph or on the board rather. So the next one is 148. 148. So I come over here. 148. Now 148 is just 8 above 140. If I add 8 to 140, wouldn't I get 148? Yes, I would. So to add 8, how many boxes will get me that 8? 4. Okay, 1 box is 142. Next one, 144. Next one, 146. Next one, 148. So 4 boxes here. 4 boxes is assumed to be here. That gives me 148. Then I can trace that out, okay, to match up with this one here. I want to believe it's just okay. So where they meet, you are starting the place there. So I can take this off, okay, take this off as well. Then we are adding 4. We have just 3 more samples there. 173. Permit me to make it even number again, 174. So I come to 174. Okay, let me get it from 180 here. If I go 1 box below 180, what is that? 178. Another box below it, 176. Another box below it, 174. So we've got how many boxes below 180? 3 boxes below 180. 3 boxes. 1, okay, 1, 2, 3. So let me now have that here. Let me assume that here. While I want to believe you're working on the real graph there, you would get a very more accurate value. So you trace this out on the graph, while this one too comes up here. Where they meet, you are stuck the place there. Okay, so I can clean this. All right, second to the last one, 194. 194 is just 3 boxes below 200. 3 boxes, because if I go 1 box below 200, that's exactly 198. 1 box below 198 again, 196. Another box below is 194. So that's 3 boxes below 200. 3 boxes below 200 is assumed to be here. You count it 1, 2, 3. 3 boxes below. So you trace it out. Okay, let me do this very, very accurate to an extent. While this one comes up to, okay, you are starting where they meet. This one goes out from here. This one leaves here from here. Then the very last, but not the least, 200. We've got that exactly here. You trace that out here. 200. Then the last class boundary. Okay, I've got that out here, so I can erase this. So the next thing you do is you join this together with a free hand, not a straight line. Not a straight line. OGIF is never a straight line graph. It is a curve. Remember the name, cumulative frequency curve. All right, so it's going to be joined with a free hand. So we've got that to be this way. All right. I think I omitted. This one should be somewhere here because I didn't do it to scale. All right, so I've been able to get the curve. I've been able to get the curve from those points. So exactly what I have on the board right there is what we have been asked to do as the OGIF, or the cumulative frequency curve as we've got there. So now the question is, how do we compute our median from the graph? Note that median can be gotten either by formula or by graph. I should do both of them to confirm. So whichever one, okay, you're good with. So let me erase the table here. Oh, I will need the table. I'm sorry. Okay, so I will need the table. All right, so here, to get the median, okay, I think that's the first question there, the median. Now, median, we need to get the median class. Median class is gotten by saying n/2 TH position. That is, you divide the sum of the frequency, that's n means sum of the frequency, which we've got the sum of the frequency here to be 200. So to get the median class, we've got 200/2. That's 100 position. 100 position. So we need to come 100 position. Then you simply come back to the graph. Because remember, we have to use the OGIF to evaluate our median. We are not to calculate median by formula. If you do by formula, when you are told to do by graph, they will just mark it down, even if you're correct with a formula. So now let's get the median from the graph. Then you simply come, having gotten the median class as 100 position, you come to the OGIF, then you locate on the cumulative frequency axis here. You will look for 100. Where can you find 100 here? 100 is here. Then you trace the 100, okay, the rule there, the line there, to anywhere it meets the curve. Okay, now it meets the curve here, then you trace it down with a straight line. Trace it down with a straight line. So the value you've got here is exactly the median value. So which we should learn how to read this value too. Let me teach us how to read it. Now, you would assume with me. Now, the median here, the value here is in between, obviously, 49.5 and 59.5. Can we get that on the camera there? I'm sure it's clear enough for them to see. Excuse me. Huh? Huh? It's clear enough for them to see, right? All right. All right, so now notice that in this axis also, from here to here, this to this one too, we've got also 10 tiny boxes also within. 10 tiny boxes also within. Here also 10 tiny boxes. The question is, now, what is the difference between each of the intervals? 10, 10, 10, 10, 10. Get that? Okay? And you've got 10 boxes in between them also. What does that mean? It means that each box is going to be 1 here. If the difference between them is 10, and you've got 10 other divisions in between them, then each box is equivalent to 1. So that means that now this point here seems to be at the middle point of them exactly. It looks middle. But I want to believe if you do on the real graph, you will get exactly the point where it intersects. It may be on the 4th point, looking like the middle point here. But permit me to use the middle point here while you do the real graphical illustration and get the answer back to us here. So here, if it's going to be assumed to be at the middle, that means you have it to be at the 5th box, knowing that each box is 1. So the 5 boxes together gives us a total of 5. So 5 added with 49.5 gives us 54.5. So the value here is said to be 54.5. So we can say, therefore, the median is 54.5. That's the median. That's exactly the median. Now, if you're not clear with that, now let me use the formula method to confirm that for you. Okay? To confirm that for you. Formula. Okay? Though we are not asked this, formula method. Okay? Now, note that median equal to L1 plus N over 2 minus FB over FM, okay, multiplied by C. Multiplied by C. Now, this is the formula if you are asked to calculate for it, rather than using the graph for it. I just use the graph to calculate the median. But peradventure you are asked to calculate for the median, this is also the way to calculate it. So now let's calculate for it, and let's juxtapose it with that which we got on the graph, and let's see how accurate they could be. All right, so here the median equal to the L1 here means you need to understand the signatures, the symbol, you know, of all of these symbols here. L1 means lower class boundary of the median class itself. N here means sum of the frequencies. FB means, notice this is a capital letter F. This is cumulative frequency before this B, before the median class. I take that again. Cumulative frequency before the median class. And this FM, notice the small case, is frequency of the median class. And this C is the class width. Now let me take us back to the table. Here we've got several class boundaries, right? So that means that we have upper class boundary here, upper class boundary, upper class boundary. Those ones we have here, they are lower class boundary. Here they are upper class boundary. So we have several upper class boundaries. So does several lower class boundaries. So here the L1 is lower class boundary of which one? Of which one among the several lower class is the lower class boundary of the median class. And that's why we got the median class too first. Okay? By the median class found to be at the 100th position. Now let me get that 100 position, 100. I get the median class from the CF. Now anywhere I get the 100 first on the CF column is said to be the median class. So let me go. The first number, can I find 107? No. Can I find 118? I do not. Can I find 135? No. Can I find 155? 184? 118? Yes. So I can find it here first. So that means that here becomes my median class. So if I mean to refer to the median class, this is what I mean. Okay. So this L1 means lower class boundary of the median class of this very class. Okay. Lower class boundary of this class. Not the other lower class boundary anymore, but lower class boundary of this class now, which is 49.5. So I've got that to be 49.5 plus, okay, Let me erase this for the sake of space here. So 49.5 plus. Now, what did I say the n represent? The sum of the frequency, that's 200. That's 200 over 2 minus. Now, the FB, capital letter FB, that should remind you very, very sweet. It means cumulative frequency that is before that median class. Now, notice this will be the median class, everybody. Now, we've got the cumulative frequency before it will be 84. So 84 is this FB, 84, okay, over FM, frequency of that same median class, which is 34. Frequency here, F, plus interval. Sorry, I erased it the other time. Okay, class mark. All right, so now over the frequency of the median class 34. Then this C here, like I said the other time, means the class width. How do you get it? You subtract the upper class boundary from the lower. That gives you 10. So the class width here is 10. So you've got that to be times 10. So finally, we've got 49.5. 200 over 2 is what? 100. 100 minus 84, 16. 16 over 34 times 10. So you've got that to be 160. I'm sure you got that correctly. Because everything I got here was what? 16. 16 times 10 already gives me 160. So 160 divided by 34. So let me get that. 160 divided by 34. Okay. Plus 49.5. So you've got that to be 54.2 as the median, calculatedly. And on the graph, what did you get on the graph? 54.5. But calculatedly, 54.2. Perhaps if you had done this correctly, okay, it could have been, now here it means that it could have been closer to the 49.5 than what we evaluated here by guess. So you do it correctly, and you see, even with this, we are very in every way close to the question. All right. So at this point, I want to put a stop to it. If you're watching this, if you're on this platform for the very first time, please just do well just before you go off, the class there. Okay, it won't cost anything. Just subscribe right down there and like, and of course share. We'll be putting up the class, shortly after now. We're putting up the recorded class online for you. You can still revisit it and get some point if you are not, if you were distracted at the point when we're doing it live. Okay, so would appreciate you to do that. Share with your friends who are having exams tomorrow, and would appreciate your very, 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 very good, comment and report from it. I want to say a very big thank you to you for taking your time, particularly those who stayed from the beginning of the class through till now. I salute you. All the best in your exams. In Jesus' mighty name. Thank you very much, and God bless each one of you. Amen. Have you stopped it?
Yes, it was